Hello, today we are going to take a look at this problem from Leetcode May challenge, remove digits. So the problem says we have a non-negative integer represented as a string, and we want to remove k digits from the number so that the new number is the smallest possible. We want to remove k digits so that the new number is the smallest possible. So the length of num is less than this and will be bigger or equal to k. And the given number does not contain any leading zeros. So given a non-negative integer represented as a string, we want to remove k digits from the number so that the new number is the smallest possible. Okay, so for example here, we want to remove 3 digits, making this number the smallest possible it can be after removing these 3 digits. Okay, so we don't have leading zeros, and the number is less than 10,002, and it's always bigger than k, right? So it's always bigger than okay, so here removing this here, we can remove 4 and 3 and 2, and this here we can remove 1. That will leave us with 200. Okay, so how can we solve this? So basically we want to remove k numbers and get and basically the data that we have is just the number and k. So I think so the brute force approach would be try removing all numbers, like basically try all permutations of or all combinations of removals, and pick the smallest one. Since basically this here, the number is less than so maybe some kind of backtracking. Okay, so I think yeah, I'm not convinced that backtracking would help a lot. So instead, let me think about this a little bit more. So we could have this, right? So for this number, what do we want to do? We could, okay, let's maintain 1, but when we find 4 here, that is bigger. Let's say we have a stack that keeps track of the numbers here as we traverse them, right? So what we'll have here is we will add 1, then we will find maybe that 4, well, we start to be here, and we'll find that 4 is bigger than, so we'll say, okay, 4 is bigger than 1, right? So actually 1 is smaller than 4, so that's fine, we keep 4. But then we find 3, well, sorry, 4, which what's in the stack, last in the stack, which is 4, is bigger than 3, right? So that means that popping 4 off, removing it from the number, will give us a smaller number, right? Because a number with 1, 4, 3, and some other elements is smaller than one with 1, 3, if we pop, like, let's say 3 instead, this is bigger if the numbers after them are the same. And so we want to remove the bigger one. And so we remove 4 from the stack, we add 3, and we advance the pointer. 2 is smaller than 3. Sorry, we want to put what? 3 is bigger than 2. Yes, it is bigger than 2, which means popping 3 off the stack is better. So we pop 3, we add 2, we advance. 2 is smaller, so 2 is equal, right? So we should also do equal, I think, because the same argument, right? If you remove that, what's after it will be smaller. So we remove this, we add the new 2, and then we have 1, right? Now what's in the stack is 2, but k is, now I should have maintained k. Every time we pop off from the stack, it means we removed the element. So at this point, we already removed 4, 3, and 2. So k equal to 0. So we should stop and just add the other numbers. So we have the number that we have left now. If we join the elements, would be 1, 2, 1, 9, which is what we are looking for here. Yep. Okay, so let's try with the stack here. So what we need to do here is, so we want to define our stack first, and then we want to go through the numbers in num, and we want to say while, and we want to, so for an element that we pop, let's say if we had encountered 2 and the stack contained 5 and 4, we want to remove both of them, right? So we'll say while k, which means it's bigger than 0, and stack minus 1, the last element, is bigger than d. We want to pop from the stack. I'll handle empty case later, and then we want to decrement k, and then we want to add say int stack and that, and then we want to append the digit just to handle empty stack case, and then we want to append the digit, and then that's pretty much it. And then here we want to join the elements, so we would say that join. We will need to handle the case where we have zeros, leading zeros, right? And so we could say join stack, right? And this would give us a string. We could convert that to s to get rid of the leading zeros. So we'll say int and then we could return, since we want the string, str. Okay, let's try with this one, k equal to 1. And let's pick the other one. $200 and okay. Okay, looks good. So let's try to submit. Before that, let's try with just something like this, and maybe 2. Okay, looks good. Let's submit. Okay, expected 0, but got. So this is with 9, and we want to remove 1. So the problem here is that we add it, but then there is no number, so we come back. That's the problem, right? So here we should, K here, we should remove just the last K elements from the stack, right? So maybe we should here do while K stack.pop and K minus 1. Okay, so if it's, when we join this, we need to say all 0 for the cases where there is nothing anymore. Okay, that looks good. Let's try it. Okay, so that's accepted. Cool. Yeah, so pretty much just doing what we said here, adding to the stack. Every time we have a new number, we check if the last number we added is bigger. If it is, we pop that number from the stack, because removing that number will give us a smaller number, a decrement K, and then at the end append that new digit. And then before calculating here, we need to get rid of any remaining K numbers that we didn't remove. And that's pretty much it for this problem.